voltage is electric potential difference. So anytime you see electric potential difference written, or generally potential difference written, it means you're talking about voltage. So immediately transfer and translate one into the other, because voltage is electric potential difference. We have this equation sitting right here. This is the electric potential energy of, or the change in electric potential energy, or the difference in electric potential energy is the charge multiplied by the electric field strength multiplied by the distance parallel to the field. And you can use that in this particular situation by placing a positive or a negative charge at a particular position here at one plate or at the other plate, and calculating to determine the amount of change in potential energy from one point to another of a particular charge as it's moved a particular displacement. So you take the charge, multiply by the electric field strength, and multiply by the distance parallel to the field. There are several really important things that are in, really important quantities in that particular equation. E is the electric field strength. So that's one quantity that's really important. E is the electric field strength. QE, that's equal to the force applied. And if you take force applied, the QE, and multiply by the displacement parallel to the field, you get work done, and that work done is equal to a change in potential energy, either positive or negative. And remember that energy is a scalar, does not have a direction. And so the last really important quantity here is that ED. It turns out that this ED is actually the voltage, as you see the equation over there. The ED, so it's Q, the charge, multiplied by ED, which is what we call the voltage, or the electric potential difference. And if you just take this electric potential energy, the difference in electric potential energy, the QED, and divide it by the charge, you have the voltage. So the definition, and it's just used because it's a really convenient concept, the definition of voltage over here is the difference in potential energy per coulomb, because you're taking the equation and dropping the charge out of it to get ED. It's the difference in potential energy per coulomb between 2 points. And I prefer to use the difference in energy per coulomb between 2 points. And that would be a good definition for electric potential difference or voltage. Again, remember that if you're asked for a definition of voltage, it is electric potential difference, and it is this basic definition right here. Because again, you're taking this equation, the QED, and taking the charge out of it and just looking at the ED. It's really convenient because you don't have to deal with the particular charges, and for situations like this, and for situations like batteries, and for situations like receptacles in the wall that you plug into, they will always provide the same voltage. So the voltage is the constant, and whether or not you plug a hairdryer or a cell phone charger into it, you get a different amount of energy coming out, energy supplied, based on the charge that's flowing through or the current. So that voltage is a really, really important thing, mostly for electricity. And this thing, again, is not a vector, but it does matter the direction you go, whether it's a plus or a minus V, positive or negative voltage, positive or negative electric potential difference, or a gain in potential or loss in potential. And that's where our preference for positive comes in again. If you take a positive charge and move it in this direction toward the positive plate, you have an increase in electric potential energy. And because you have an increase in electric potential energy for that preferred positive charge, this plate on this side, the more positive plate, or the positive plate in this side, in this case, has a higher potential. And so the other side, the negative plate, has a lower potential. So if you're going from higher potential to lower potential in this direction, that would be a loss in potential, or a negative potential difference. So if you have motion in that direction, that means that that is a negative voltage. And the opposite is also true. If you have motion in this direction, that is a positive voltage. Again, this is just by definition. It doesn't matter what charge you put in this field. The positive negative voltage concept is defined by a positive charge placed in that field. You place a positive charge in this field and move it in this direction, It gains potential energy, so that's an increase in potential, which is the potential energy per positive coulomb between 2 points. And if you move it in this direction, from the positive to the negative, it's just like lowering something in a gravitational field. And lowering something in the gravitational field decreases its gravitational potential energy. And the same thing here with the positive charge. It decreases the electric potential energy. It is a loss of potential energy. It's a loss of potential and a negative potential difference. So that's how we determine this. Again, remember, these positives and negatives are not directions. Positives and negatives in all energy and voltages represent a gain or a loss. It's not a vector. Remember, electric potential energy per coulomb between 2 points is the definition for voltage and also the definition for electric potential difference because they are the same.